most organic compounds are actually polar, and it therefore makes most organic compounds to actually have a part that is actually nucleophilic, while the other part is electrophilic. For instance, let's use the first example, which is methyl bromide. Now, methyl bromide is actually this methyl bromide bonded to bromine. Now look at this. This is actually polar. And why is it polar? Because you have an electronegative atom, bromine, and you have carbon, which is not as electronegative as bromine. So what will actually happen is that bromine, the electron cloud will be shifted more to bromine, giving bromine a partial negative sign, while for carbon it will be having a partial positive sign. And this eventually will make this part to actually be nucleophilic, while this carbon here becomes electrophilic. Now remember, the reason for this is because it is polar, and that is due to the electronegativity of bromine. Once you have a more electronegative atom, you will see that the electron cloud seems to be situated on that atom, and then it causes this kind of phenomenon. Now, in the same methyl bromide, we're having a part that is nucleophilic and another part is electrophilic. Let's look at another example. Another example is what is known as methanol. Methanol, let's say that's methanol. Now methanol is this. Now in methanol, you can see something. We are going to be comparing carbon and oxygen. Oxygen is more electronegative than carbon, hence it has a partial negative charge, while carbon will actually have a partial positive charge, and this eventually makes the oxygen part to actually exhibit nucleophilic properties, meaning that it has so much electrons, is electron rich, while this is actually what? Electrophilic. Now this can also be seen in a third example we'll be considering. Let's consider this example, propanol. Let's consider propanol. Now propanol is actually this. Okay, let me do it better. Now this is actually propanol. Looking at propanol, we have an oxygen and a carbon. Oxygen is more electronegative than carbon, hence it will have a partial negative charge, while carbon will have a partial positive charge. Now this will now cause this part of the molecule to act as a nucleophile. It will be nucleophilic, while the other part to act as what? An electrophile. And remember that nucleophiles will always attack electron deficient centers. So it means that this nucleophilic part, oxygen, will actually be susceptible to electrophilic attack, while the partial positive side, that's the carbon, will be susceptible to nucleophilic attack. And this is because of the polarity of the bonds in organic compounds. Remember, if the compound is actually polar, one side seems to act as an electrophile, while the other part acts as a nucleophile. Don't forget that electrophilic centers are electron deficient centers, while nucleophilic centers are electron rich centers. Thank you.